Hi, welcome to another Level 3 probability distributions video. We're now going to start chatting about the binomial distribution. Now the prefix bi means two, and the binomial distribution is a set of discrete data that has just two outcomes. Discrete data is data that's counted, and it must be whole numbers. The outcomes are often referred to as success and failure. Here are the conditions that must be met for binomial distribution. There's only two outcomes. The probability of success must stay the same. The number of trials must be fixed. And each occurrence is independent of others. We'll come back to these conditions really shortly. Here are the parameters for binomial distribution. P is the probability of success. Q is the probability of failure. And note Q is just 1 minus P because P plus Q add up to 1. And N is the number of trials. All right, let's get into our example. In a multiple choice test, there are 4 answers to choose from. Jessie has not studied and guesses the answers. There are 10 questions in the test. All right, so let's come back to these conditions. There are only 2 outcomes. Well, that's true because we either get the question correct or we get it incorrect. The probability of success must stay the same. Now, because we have 4 answers for every question, we can say because he's guessing and it's a random choice, the probability of success is 1 chance in 4, and therefore the probability of failure is 3 chances in 4, and that stays the same for all 10 questions. The number of trials must be fixed. Well, there are 10 questions, so n is 10, and each occurrence is independent of others. So we're going to assume that no question has a dependence or affects another question in any way. All right, so our parameters we've worked out. P is the probability of success, which is 1/4 or 0.25. Q is the probability of failure, which is 3/4 or 0.75. And N, the number of trials, is equal to 10. Right, let's grab our calculator and go into statistics. Find the distribution menu, F5, and find the binomial menu, F5. Inside there, we're going to select the binomial point distribution. And we're going to select a variable if you're not there already, and we're going to enter in our parameters. So let's enter in P for 0.25, N is 10, and let's start with X 0. That's getting 0 marks out of 10. Right, that gives us a probability of 0.05631, and let's set up a distribution table, and we can put in our first value. Probability of getting 0 marks out of 10 is 0.0563. Now we can go back and we can repeat that and put X as 1 and get a probability and enter that into our table. The probability of getting 1 mark out of 10 is 0.1877. We can do the same for X as 2, and that gives us a probability of 0.2816. And then we can complete the whole table by repeating this process for all the other X values up to 10. All right, now I've drawn a probability distribution graph. We can see that the highest probability is getting 2 marks out of 10. That's 0.2816 or 28.16%. The next highest is getting 3 marks out of 10, 0.2503 or 25.03%. The lowest marks are right down at getting 7, 8, 9 or 10. In fact, the probabilities for 9 or 10 were so small, I've just rounded them to 0. All right, here's the question we're going to answer for this example. What is the probability Jessie scores more than 5 out of 10? Well, the probability of getting more than 5 means either 6, 7, 8, 9 or 10 out of 10. So we can either read off the graph or read off the table, and we can add up all these probabilities. So to work out the probability of being greater than 5, we just add up all these probabilities to get the probability of being greater than 5 of 0.0197, which is equivalent to 1.97%. About 2% chance that Jessie would get more than 5 out of 10 in the test by guessing answers. Right, there's our first video for binomial. So thanks so much for watching.